The deluge of data collected by the thousands of sensors deployed at a city scale need more intelligence to understand what's happening, take quick decisions, and very importantly, evolve over time. From a technology perspective, we need to bring together key technologies such as artificial intelligence, machine learning, Internet of Things, edge and cloud computing in a way that does not lock the users into a specific commercially controlled set of services or technologies. All this is complex to put in place. MEDINA addresses these problems by delivering a solution that can be run as a service by our industrial partner 6Square.
There is an explosion of data happening around the world, and conventional wisdom so far has been to push all the data to the cloud for processing. Well, that's just not working. Even with 5G deployed everywhere, there is just too much data. It's the wrong approach. Instead, we need to do it the other way around, where we process the data like video and audio streams closer to their source. That is what is known as edge computing. On top of addressing the issue of the amount of data processed, the edge computing approach also brings additional key advantages such as avoiding privacy intrusion issues because the video streams are not going over the wide area network. Second, no more round trips to the cloud and back, which takes time, and it reduces network and storage costs. A concrete example of edge computing, and one we've worked on in a tight collaboration with the Geneva Business School, is dynamic street lighting on busy streets, roads, and highways. The idea is to adjust the level of lighting based on the density of traffic. The logic behind that is the more traffic there is, the more lighting we need to provide to keep the street safe for all of its users. To do that, we use a video camera connected to an edge device. The edge device runs a machine learning application which categorizes each vehicle and counts them anonymously. This information is then used to decide in real time if the street lights of the segment of road must be increased, reduced, or left alone. All this logic is done locally without the need for a round trip to the cloud and without any intrusion in the privacy sphere of citizens. However, if the machine learning application cannot correctly identify a vehicle, then the cloud is notified with the images that has caused difficulties with. Eventually, this triggers a new learning cycle, resulting in a new version of the machine learning application, which gets pushed back to the edge devices.
Concretely speaking, MEDINA aims to reduce the total cost of ownership of edge-to-cloud modern IoT application by providing an IT ecosystem composed of a set of services used to develop, deploy, and monitor this kind of applications in a seamless way. Here, edge-to-cloud modern IoT applications means self-adaptive machine learning-based IoT applications deployed on edge-to-cloud infrastructure where the edge intelligence is improved by the cloud. The edge device learns from the cloud and adapts its intelligence to match its local context. This ping-pong game between the cloud and the edge can be represented by a closed feedback loop. From a software engineering perspective, MEDINA will lead to a new paradigm of continuous integration software applied to these edge-to-cloud modern IoT applications.
We see that edge computing is more and more used in conjunction with machine learning applications. Therefore, the results from this project are directly applicable to a range of applications and a variety of market segments. We have already integrated early results of this project in our Nuvla.io marketplace released in December 2020. It brings together technology but also terms and conditions and a pricing model that allow us to run the very first edge computing marketplace for business applications as a SaaS, therefore generating annual recurring revenue, which is the gold dust in our industry. The last piece of the puzzle that 6Squared is working on in the context of MEDINA is governance, on which we are working tightly with HESSO. Since edge computing and machine learning generally imply digital transformation for organizations adopting our services, it is paramount for us to be able to articulate a sound governance policy with them. This means that users of our services remain in control while they adopt edge computing and machine learning to improve their performance as well as deliver better services for their users.